So that's 1.2, solve two-step linear equations. So in the last section, it was, hey, use one principle of equality to solve the equation. Now we're saying it's two steps, so naturally that means we're going to end up using two principles of equality to solve these equations. Principles of equality, same principles, just we may need more than one at a time. And in this case, this particular section, we're looking at two at a time, right? And just so everyone understands, addition and subtraction, when you look at these two principles of equality, you're looking to, really you'd be looking to make zero on these, okay? We use these two to make zero. Right, when we want to force a value to be zero, we use addition or subtraction principles of equality. When we get down to multiplication or division, I don't know if that works, but then we are trying to make, maybe you guys noticed from that last section, right here we're trying to make ones. Okay, and can we force values to be one? Sure. As long as we're using the principles of equality, we can do that, right? But mainly, we're going to use these four to make zeros or ones, okay? And the process here is to really force the values to being one to go away because they become phantom zeros, or to make the coefficients ones to make the coefficient a phantom one so that we don't have to look at that garbage, okay? But two-step equations, we're going to need two of these. So here we go. Here's this one. If your answer is a fraction, we'll write it as a fraction, no problem, right? So we got negative 12x minus 16 equals negative 8. Remember, our goal here in the end is that this look like x equals 0, right? I'll check this one with, I'll write not 0. Why did I say 0? I want x equals something. I don't care what the value is. It just has to be equal to something. But I'm going to use principles of equality to do that. Yeah, no decimals, it looks like. So, well, how are we going to do that? Well, in the principles of equality, you usually want to make zeros first and then ones. Another way you'll hear this is you want to isolate your x's. What that means is from the current equation, I don't want this to be negative 12x minus 16. I just want it to be negative 12x. See that? Which means that the minus 16 or the negative 16, I got to zero that out. So how do I make a negative 16 a 0? I just add 16 to it, right? That's a 16, by the way. If I do it to one side, I got to do the other side, though. So add 16 there. Now I got negative 8 on the right side. I got negative 8 plus 16, which is positive 8. There we go. All right, hey, this is now a one-step equation because all I have is a coefficient, a letter, and it equals some other number, okay? So what am I going to do here? Well, I want to make that negative 12 a phantom 1. How do I do that? Remember to make ones? It's either division or multiplication. Right now it's negative 12 times x, so I'm going to use division. Negative 12 divided by itself is 1. There's our phantom 1. But if I do it to one side, I got to do the other side. 8 divided by negative 12. You can simplify this with a calculator. It will do it for you. This will come out as a negative 2/3 right there, okay? Now, as promised, I said I'd check this, so here we go. Negative 12x minus 16. Just writing the original equation, right? We do want to check in the original, not at some point in between. And right here, I'm saying that x equals negative 2/3. So I'm going to replace that x with negative 2/3. Let's see if we can do that. Negative 2/3. Hopefully that's big enough to see. But I'm going to multiply that now. So I'm checking for truthfulness. Here's my question mark, right? So I got negative 12 times negative 2/3. So for me, I'd cross simplify. Negative 12 divided by 3 is negative 4. Negative 4 times negative 2 is negative 8, right? No, positive 8 because there are two negatives. So it's positive 8 right there. So I got positive 8 minus 16. See how this would be nice with a calculator? 8 minus 16, what do we get? That's a negative 8 right there. Well, does negative 8 equal negative 8? Yeah, that's true. So since it is true, I now know that my original answer, x equals negative 2/3, is the solution. It is important to see that I use two principles of equality, right? I use the addition principle of equality, that was to make 0, right? With the negative 16 plus 16, yeah, I should have put a 0 there. I'm not circling it, I'm putting a 0 there to show that it became a phantom 0. And then I use the division principle of equality. Boom, done. But it only takes two of them in this section. Here's another one. We got a two-step equation. We want to write this, whatever the answer is, as a fraction. Okay, yeah, let's go and do this one too. And so, principles of equality. I don't want this 2x plus 7. I just want this right now to just be 2x. That's isolating the x's. The x's are by themselves. I don't want to be adding or subtracting anything to my x's, however many that I have. Right now I got 2 x's, right? So I got that plus 7, I got to zero it out, so I'm going to subtract 7. If I do it to one side, I must do it to the other side, because that's the principle of equality. Well, I'll work from left to right here. Negative 18 minus 7, I get negative 25 in that one. And you can see I just dropped the 2x right there. And then I got 7 minus 7, that's 0. Now, again, that means that you could be showing this plus 0 right here, but there's no need to do that because you're not adding value to it. It's just 0. It has no value. Last thing I'm going to do, so we use a subtraction principle of equality. Now, I'll use the division principle of equality by dividing both sides by the coefficient, because that's 2 divided by 2, which is 1. Phantom 1, 1x equals, well, negative 25 halves. Now, you could write this out and check like I did on that last problem, even though it's a fraction. And you could use the fraction button on the calculator, but let's check. 2 times negative 25 halves, that'd be negative 25, and then plus 7, that'd be negative 18. Boom, it checks off. Your calculator will tell you the same thing. It is true. So x equals negative 25 over 2 is the solution to our original equation here. Here's this one. 8 equals 6a equals, 8 minus 6a equals negative 4. You know, you guys take a minute and try this one out, okay? Well, just off the top of my head, just so you can check your answer, what I got is a equals 2, right? Let's check. I did that in my head, and I tend to make mistakes in my head. Let's make sure that it is true, okay? So I don't want that, that 8 with that minus 6a right there, which, by the way, really is the term negative 6a, all right? I don't want that 8 there. I got to zero that out. That's positive 8. How am I going to make it 0? Let's subtract 8 from both sides. There we go. So I subtract 8 from both sides. That is 8 minus 8, which is 0, just like we wanted. I'm going to drop this. Now be careful you do drop this as negative 6a. That's important, all right? The operation to the left there was subtraction, which makes that term negative. If it were addition, then it would have been positive, okay? And then moving to the right, I got negative 4 minus 8. That's how that would read, which then would be negative 12. And some of you can do the rest in your head, whatever. But I'm going to use the principle of equality. I don't want that to be negative 6a's. I want 1a's right there, phantom 1. And so I'm going to divide both sides by the coefficient negative 6. That does, what the heck? That becomes a phantom 1 right there, but I'll do it to both sides because that's my principle of equality. Well, that becomes a phantom 1a. Negative 12 divided by negative 6 is 2, positive 2. And we can check. What is 6 times 2? That'd be 12. 8 minus 12, it does equal negative 4. That's true. All right, here's another one. And, you know, if we need the answer to be a fraction, then we will. We'll give you 1 minute, and then we'll come back and do it together, all right? All right, so again, my objective right now, I got to get rid of that 4. I don't want the 4 there. I just want the negative 14x by itself. So how am I going to get rid of that 4? I'll make it bigger first. But I'm going to have to subtract it from itself. That is going to make it a 0, which is what I do want, because that will be now a phantom 0. But if I do it to one side, I must do it to the other side, which gives me then negative 38 minus 4, which would be negative 42. And this is going to equal, we already zeroed out the 4, right? So I'm going to drop my negative 14x there. So now I have this reads negative 42 equals negative 14x. And what do I need now? I want 1x, not negative 14x's. So I'm going to divide it by the coefficient, negative 14. If I do it to one side, I must do it to the other side. Looks like x is going to be 3 on that one. Let's just check, though. Let's just check. Well, what is 14 times 3? That'd be 42, right? See, we get that 42 right there. It's negative 42, by the way. What is 4 minus 42? Well, that's negative 38. So it does check off. And you'll see if you check these at least one step at a time, that the values that you're solving for or with, they kind of reappear as you go through those. So we checked to make sure that was true. It was. And so now I know that x equals 3 is the solution there.